All right, so today we are going to move on from transverse waves and talk about longitudinal waves. So the first thing I wanted to do today was to go back over and look at our first activity in waves and my portfolio, because I wanted to look at and complete that first activity where we were just describing the characteristics of waves. And so I completed this diagram in the middle on longitudinal waves. So a longitudinal wave, the particles are moving back and forth in the same direction as the wave is moving. So longitudinal waves are pressure waves. So this includes sound, ultrasonics, and some things that are kind of fun to work with and to deal with. So moving in the same direction, where a transverse wave, the particles would be moving up and down while the wave was moving side to side. In this case, longitudinal, particles are moving back and forth, side to side, and the wave direction is side to side. All right, so what we are doing today is going to be working on ultrasonics. And ultrasonics are a couple of different um, uh, applications, but one of them, or several of them, are outlined in this article that I'm going to have you go through on ultrasound. So it talks about echolocation. This is things like how bats or whales identify things around them. Ultrasound can be incredibly accurate. Bats are able to go and identify a tiny insect while the insect is flying and the bat is flying, and the bat is able to capture the insect for food. Ships use sound, same way echolocation. They call it sonar, where a ship might locate an underwater obstacle like a mountain or another ship like a submarine. And then they go through a little calculation. Distance to that object is speed of the wave times the time it takes for the wave to get from the surface ship to the submarine. Remember that the surface ship doesn't know how long it took to get to the submarine. What it knows is how long it took to get to the submarine and back, round trip. So whatever time is the round trip time, you have to divide by 2. So in this case, if the sound wave took 2 seconds to return to the surface ship, it only took 1 second to get to the submarine. We know that underwater sound travels at 1,437 meters per second. So therefore, we can calculate the distance from the surface to the submarine. Other uses of sonar for finding topography, mountain ranges, obstacles, sunken ships, all sorts of things underwater using ultrasound and echolocation. Ultrasound also has a purpose in medicine, and so there's a little video here to watch about that. When you're all done with that, then you will go back over to Seesaw, and there is a, there we go, little set of questions. What is ultrasound? How do animals use echolocation, etc.? And you're just going to complete that activity. So that's what you missed if you weren't in class today. I will see you next time.